Go! Okay, so the homework this week started with a factor theorem, remainder theorem type question, and went on to some logarithms. So here we go. A cubic polynomial is given by that. If you can't see it well enough, then there it is. X cubed minus 2x squared minus 40x plus k. There we are. Where k is a constant, it is given that when f of x is divided by that, the remainder is minus 144. Find the value of k. Well, all we do with this is we interpret this as meaning f, that's going to fade away now, f of 2 is equal to minus 144, because that's what the remainder theorem says. So there's no need to do long division, we just go straight in with that. So this means that 2 cubed minus 2 times 2 squared minus 40 lots of 2 plus k is minus 144. And we've got a simple linear equation in terms of k, which we now need to do something with. Well, this is 8. Take away 8. Minus 80 plus k is minus 144. So k is minus 64. And that was it. Was that really all that there was to it? Oh, 3 marks. Done. Okay, you could have dived into some awful long division and you would have got there in the end, but it's a bit messy to have to use k in there, but it would have still worked. Question 2. Use logarithms to solve this equation here. Give the answer correct to 3 significant figures. Now I think this is a very carefully designed question so that 3 to the 700 is so big that your calculator can't handle it. So you can't do it by a kind of trial and improvement or kind of any other guessing route. So we have to actually go through the steps. Now remember, to solve an equation with an unknown power where we haven't got the same base number, we take logs of both sides of any base, but we are going to choose log base 10. As our first step. And we have that law of logarithms we did just before Christmas that says that the power comes down to the front. So we have 4x minus 1 times log 2 equals 700 times log 3. We now have an equation in terms of x that we need to rearrange. We could write these values, but we won't. We'll leave them in exact form. I'm going to divide both sides by log 2. We then need to unpack this till we get what x is, so we're going to add 1 to both sides. And then divide both sides by 4, and hopefully that gives us an answer which I have to admit I haven't worked out yet. Could I borrow a calculator? Did anybody get a calculator for Christmas? No. You did? Was this a new Christmas present? Yeah. Oh, it's, there we are, a Casio FX 991 ES Plus. Lovely. Oh, it's so new that the light is glinting off the silver plastic and almost blinding me. So we've got a quarter. We can use this calculator's delightful fraction notation there. I'll just get on with it. 700 log 3 over log 2. The suspense is very suspenseful. It says 277.618. And the question said, give your answer to 3 significant figures, so we're going to say x equals 278 to 3 significant figures. There it is. I'll turn off the FX 991 ES Plus, turn it to its case. Right. Was Was that your main Christmas present, Ben? Oh. Wow. Does that imply that you got something better than that for Christmas? No. Okay, so the next question. Given that P is log base A of 25, express log base A of 5A in terms of P. Part of the problem here is trying to work out actually what we're being asked for. We're asked to do something with log base A of 5A. So let's use our laws of logarithms. Let's split this up. This is log base A of 5 plus log base A of A. You know that. And log base A of 5, the question says, oh hang on, the question says log base A of 25 is P. And we've got log base A of 5. Well, that's the same as log base A of 25 square rooted, isn't it? Yeah, because the square root of 25 is 5. And log base A of A is equal to 1. So this bit here is a half of log base A of 25. And so the answer that we're looking for is a half of P plus 1. Did we get that? Did anybody get that? So that was quite tricky. The difficult bit at the start was recognising that if we take this statement here, that statement there says that P is log base A of 25. This may have been a better way of doing it, which is log base A of 5 squared, which is equal to twice log base A of 5. So another way that we could have got to it is we could have said, therefore, log base A of 5 is equal to a half of P, and we could have done it like that. So either direction that you went from, you would have ended up with that as your answer. So that's a half P plus 1 there. Right, part B. Now this is unconnected, so now we're going to solve this equation. It's a log base 2 of 5x plus 4. Sorry, 5x plus 2 minus log base 2 of x equals 4. Now before we do anything with this, we've got to get it so it's one term on each side of the equation. So this is log base 2 of 5x plus 2 over x, because when we subtract two logarithms of the same base, we divide. So this now says, remember that law of logarithms we wrote down? We said that log base A of b equals c, means the same as a to the c equals b. Those two statements are equivalent. So here we've got a to the c equals b. 2 to the 4 equals 5x plus 2 over x. And now we've got an equation we can work with. Let's get that x up onto the same line. So we've got 16, 2 to the 4, x is 5x plus 2. So 11x equals 2, so x is 2/11. And we've solved that one as well. And that was 5 marks for that second bit. We got a lot more for the first one, which was probably a lot more for the second one than the first one. Okay? Are we all happy? Rachel's going to stop the video in a moment, and that's maths.